How we doing, guys? Text and test 4. We're looking at pages 29 to 31, questions 2, part 1, question 6, question 7, and question 11. This is all about rearranging algebraic formulae. So you've met most of the rules we've been working with for the junior cert and other places before. Just to do a quick run through, with this first example, you've got 2x minus y over 3 equals 1 over 3. They want you to write x in terms of y. So rejig this formula so that you get y by itself. Now, there's more than one way to do a lot of these, so you might find yourself using a different method to what I use in the video or in class and getting the same answer, which is perfect. There's nothing wrong with that. Just to give you one simplified example here, if you were told 2 multiplied by 3 minus 2 equals 4, hopefully that's fair enough. This is a relationship between these sets of numbers. The same relationship could be expressed as 2 multiplied by 3 equals 4 plus 2. That the minus 2 on the left becomes a plus 2 on the right. We're hopefully used enough to that. If you're trying to get the 2 by itself, you might say, well, then 2 is the same as 4 plus 2, all, if it's multiplied by 3 on the left, divided by 3 on the right. So we're just rearranging formulae to get, say, one number by itself. So that's what we're trying to do up here. Minus y over 3 on the left is going to move over. We're trying to get x by itself, so we'll say that's the same as 1/3 plus y over 3 on the right, which is the same as y plus 1 all over 3. So then x is going to be y plus 1 over 3 divided by 2, multiplied by 2 there, it's divided by 2 here, which is y plus 1 over 6. Question 6 gives you this formula here. It's called the pendulum formula. It asks you to find L by itself. So to get L by itself. So in this question, you've got a square root. If you ever want to get rid of a square root, you need to square both sides or isolate the square root and then square both sides maybe more commonly. So I'm going to do that first. I'm going to say, well, that multiplied by 2 pi on the right. I'm going to move it over to the left and I'm going to say that's t divided by 2 pi is the same as the square root of L over G. Now, the opposite of a square root is a square, so if I want to move that square root over, I'm going to square on the left hand side, or alternatively you can say square both sides of the equation. Either way, you're going to get t over 2 pi squared is the same as L over G, so we're almost there because we want L by itself. That's L divided by G, so that's going to be multiplied by G on the left hand side. G multiplied by t over 2 pi squared is L, or if you wanted to tidy that up, you might say L is t squared over 4 pi squared, when you square that out, times G. Okay, there's an expression for the length of a pendulum that has a period. T is the period of the pendulum. What this formula is used for, you don't need to worry about. It's the rejig is what we're working with if this was physics. I might go into a bit more detail. The second part of question 6 says, given that the period is 3 seconds, t is 3 seconds, and g is 10 meters per second squared, calculate the length of the pendulum correct to one decimal place. Okay, well, the length of a pendulum of period 3 seconds when g is 10 meters per second squared is going to be 3 squared. 3 squared times g is 10 divided by 4 pi, and that's going to be 90 over 4 pi, which when you go to your calculator, 90 divided by 4 pi is going to be 7.1. 7.2 meters to the nearest decimal place. Question 7 gives you, in each of the following expressions, express A in terms of the other variables. So it gives you this. We want to get A by itself. Now, where you've got what you're trying to get by itself crops up in two different places, you're probably going to have to take a factor of A at some stage to get it by itself. So I'll show you what I mean now. If I cross multiply here as my first step, I can say x multiplied by A minus B equals A plus B multiplied by y. Okay, so that's divide on the left, or on the right, it becomes multiply on the left. That's divide on the left, becomes multiply on the right. That gives us ax minus bx equals ay plus by. Okay, now I'm trying to get a by itself, so I need to put all the a terms together and all the non-a terms together. So I'm going to take this minus bx and make it a plus bx on the right hand side. I'm going to take this plus ay and make it a minus ay on the left hand side. So I get ax minus ay equals plus bx plus by. And now I can take a factor of a here. So now I only have one a in the equation, as it were. You might take a factor of b over here just for tidiness, but to get a by itself, that says a multiplied by x minus y, so you're going to divide by x minus y on the right hand side, and there is a by itself. Okay, you're going to be doing part 2 there for homework, so that's kind of it's not a step-by-step or anything, but it's the same principle for part 2. Question 11, the last one we're going to look at, says a cone has a radius r and a vertical height h. The slant height L is 15. Using Pythagoras' theorem, express h in terms of r. So using Pythagoras, we'll do that. Hence, find the value of h when r is 5. Okay, we'll do that in a second. And what value of h will the radius be half the slant height? So first of all, Pythagoras says r squared plus h squared equals 15 squared. So h squared is 225 for 15 squared. That's plus r squared on the right, on the left becomes minus r squared on the right, and h then is the square root of, because h squared, the opposite is the square root of 225 minus r squared. Second part, hence find the value of h when r is 5. H is going to be the square root of 225 minus 25, and that is the square root of 200, which is 10 root 2, or if you want to go to your calculator, root 200, excuse me, is 14.14. Third part, what value of h will the radius r be equal to half the slant height? So if we want r to be half of the slant height is 7.5. So they're saying, well, h then would be the square root of 225 minus 7.5 squared, which is 225 minus 7.5 squared is 168.75, and the square root of 168.75 is 12.99. which, if it's correct to the nearest centimeter, that is 13 centimeters, will give us half the slant height. Now, can I ask you now, please, to do question 1, all of it, okay, and then question 7, just part 2 from question 7. In class tomorrow, we'll do 2, 3, 5, and we'll finish 8 to 12 if we have time. Thank you.